Okay, so we're going to start chapter 3 by talking about quadratic functions. So I'm pretty confident that you guys have seen quadratic functions, but I'm still going to kind of start from the beginning and make sure that if, for those of you who need to have your memory refreshed, you don't have to worry about me assuming that there's things from it that you need to know and I'm not going to cover. I will cover everything from the ground up. So let's start off by talking about what it is when we have a quadratic function. Okay, so whenever you hear the name quadratic function, you need to think of a function where the highest degree is of power 2. So we're going to basically say a quadratic function is a polynomial function of degree 2 of the form f of x equals to ax squared plus bx plus c. And remember, a, b, and c are going to be constants, but more specifically, a can't equal to 0. And hopefully you guys understand why a can't equal to 0, because if a is 0, then I will have bx plus c, which that becomes a linear function, so it's no longer quadratic. Okay, so now let's talk about what it means for a quadratic function to be in standard form. So we want to talk about the standard form of a quadratic function. Okay, so we can say a quadratic function which is defined as f of x equals to ax squared plus bx plus c can be written in standard form as f of x equals to a parentheses x minus h quantity squared plus k. Okay, now why is the standard form important, or why is it convenient? If you guys remember, all quadratic functions, every quadratic function has a vertex and an axis of symmetry. Those are probably the two most important characteristics or properties of quadratic functions that we want to identify. So when you have it in standard form, we can see what the vertex is. So this will be with a vertex of h comma k and axis of symmetry x equals to h. Okay, so if you remember, there is always a vertical line that we can draw that would cut the graph in half, and it's basically the x value of h. And if you guys recall, the axis of symmetry always went through the vertex. So if you think about it, if it goes through the vertex and it's a vertical line, then the x value of the vertical line has to be the same as the x value of the point of the vertex. Okay, so it shouldn't come as any surprise to us. So a couple of comments I want to make before we do our first example. So note, the first thing I want to say is quadratic functions can be written in standard form by completing the square. Now, hopefully you understand why we care about thinking of it in terms of completing the square. Main reason being, look, notice how we have a perfect square here. So to go from this guy to that, we would need to complete the square to get a perfect square out of it. So we will do an example in a minute where you'll see how that works the way it does. Okay. Now, the second comment I want to make has to do about the value of a here. Okay. So what we could say is if a is greater than 0, then the parabola opens upward. So basically what I'm saying is it's going to look like this, okay? And since I've drawn this parabola, or if you remember, the vertex is the point in which the parabola changes directions, like it's going down then up, and vice versa if it's going downward. And in my axis of symmetry, notice how it does that. It cuts this in half. Okay, so that's basically what I mean by vertex and axis of symmetry. And notice how the axis of symmetry goes through the vertex. Okay, now if a is less than 0, or it's a negative number, then the parabola opens downward. So in this case, we know that we have a parabola that looks like this. That's our vertex again. In this case, notice how it changes from going up to down. And then we still have our axis of symmetry here. Okay, so these are some things that for you to remember and characteristics. So let's look at our first example where we'll put this to use. So for example 1, we're going to say let f of x equal to negative 3x squared plus 12x minus 13. Okay, so the first thing we want to do is part A is express f in standard form. Okay, so to do that, we're going to need to complete the square, as I mentioned. Now, let's start off with our function f of x equals to negative 3x squared plus 12x minus 13. So there's a couple things I'm going to do. The first thing is, to complete the square, the number in front of the x squared has to be a 1. So since this has to be a 1, I'm going to have to factor out a negative 3 from this. And this constant I'm going to ignore. It's not, when I say ignore, it's not that I'm going to get rid of it, but to be able to complete the square, if you guys remember, we're going to add the number. Okay, so we need to decide what number to add. But before we do that, we first need to make sure, in order to be able to complete the square, this has to have a 1 in front of it. So right now it doesn't. So if I factor out a negative 3, and I'm only factoring out from these two. Okay, that guy I'm leaving alone. Which if I factor out a negative 3 from these two, what do I get? I get x squared minus 4x. And I'm going to leave some space because I'm going to be completing the square, minus 13. Now, if you're confused by this, or if you're ever confused, it's like, hey, did I do the right thing here? I'm not sure if this is correct. Well, go backwards. If I distribute this back, notice how you'll get back to that. Now, if I was to distribute the negative 3 and I didn't get this back, then I did something wrong. But we're okay, right? So negative 3 times x squared is negative 3x squared. Negative 3 times negative 4x is plus 12x. And then the minus 13, it's matching up. So now let's complete the square. Now if you guys remember, to complete the square, we would always take the number in front of x, we would cut it in half, which if I take negative 4, cut it in half becomes negative 2, and then we would square it. And when you square negative 2, what do you get? Negative 2 squared is 4. So to complete the square, I'm going to be adding a 4 here. But remember, if I'm adding a 4, I need to keep this balanced. I also need to subtract this 4. But let's be careful though. I'm not really adding a 4. What am I really adding? I'm really adding a 4 times negative 3. So in reality, I'm adding a negative 12, aren't I? So to keep this balanced, since I'm adding a negative 12 because of the negative 3 times 4, I also have to add a positive 12 because I want to make sure that this is balanced out. If I just add the negative 12, then I'm changing this problem up. Now I promise you, if you're not sure, if you distribute the negative 3 and then you simplify this, I promise you that you're going to get that back. Okay? So with that said, now by adding this 4, I've been able to complete the square here. So now this becomes a perfect square when I factor it. So it'll be negative 3 times x minus 2 squared minus 1, because the negative 13 plus 12 gives me that. Now there it is in standard position. Now let's go on to part B, which is going to use part A. So in part B we're saying find the vertex, x-intercept, and y-intercept. Okay, so to do this, the vertex is not difficult to find because since we already found this in standard position or standard form, we know that the vertex is 2, negative 1. Okay, now we also need to find the x-intercepts and the y-intercepts. Well, to find the x-intercept, if you remember at the x-intercept, what is it that we need to do? We set y equal to 0. So we grab this, we take negative 3 times x minus 2 squared minus 1, we set it equal to 0, because to find the x-intercept, if you remember at the x-intercept, your y is 0. So now we could solve for this. So if I add 1 to both sides, I get negative 3 parentheses x minus 2 squared equals to 1. Divide by negative 3, and what does that give me? X minus 2 squared equals negative 1/3. And sure enough, if I square root this, I get something that doesn't exist. So what does that mean about the x-intercept? As far as the x-intercept goes, since I got something that's no solution, this is none. Okay, now to find the y-intercept, we do the same thing, except now what is it that we do? We let x equal to 0. Now if x is 0, what do I get? I get y equals to negative 3 times 0 minus 2 squared minus 1, right? All I did is replace x with 0. That becomes what? 4 times negative 3 is negative 12, plus negative 1 is negative 13. And there's our y-intercept. So our y-intercept, remember, it's a point. It's 0, negative 13. Okay? So then, let me go to the back page. Part C is saying, sketch the graph of f. Okay. And if I'm sketching the graph, if you remember, what was our y-intercept? 0, negative 13. Our vertex was, what was the vertex? It was 2, negative 1. So I'm going to shorthand this, but it was kind of like somewhere here. And we know that it's going to open downwards like that because a was a negative number. But this is a rough sketch. We could probably do a better sketch of this, but this is kind of gives us an idea as to what it looks like. Okay, so there's our sketch. Now for part D, we're being asked to find the domain and range. And that's not difficult to do because what is it that we notice? We know that the domain is just all the x values, which notice how this goes forever to the left and forever to the right. So the domain is all real numbers. The range is all the y values it takes on. Now notice the largest y value this takes on is negative 1. So it actually comes up to negative 1 and then it goes down forever. So the range is what? From negative infinity to negative 1 because it doesn't go any higher up than negative 1. Okay? So now the next thing we're going to do is we're going to talk about maximum and minimum values of quadratic functions. So there's actually a comment we can make about the maximum and minimum of quadratic functions. Now hopefully this next statement I make will make sense to you guys, but quadratic functions can either have a maximum or a minimum. Okay, so they could either have a maximum or a minimum, but let me move this up a little so you could see it better, but can't have both at the same time. So I guess what happens is, well then, that kind of gives us, we arrive at our first question that I have for you guys. So you might want to, after I ask you this question, you might want to pause the video, think about it, and then press play and see if your answer matches up with mine. So where does the maximum or the minimum occur of a quadratic function. And if you think about it, the answer is at its vertex. Because if you remember, the vertex is the point in which the quadratic or the parabola changes directions. So which means it'll either be a minimum or a maximum. So then we could even be more specific. So if a is greater than 0, if you remember this is the number that a we were talking about earlier, what does that mean? The parabola, this implies the parabola opens upward and we have a maximum. Or sorry, and we have a minimum. We have a minimum at its vertex. Okay, so, and the way we would say it, if you remember, we identify the location by the x value, but the value, the minimum value, is the y value. So we would say, for example, if it's in standard form, at x equals h, that's where you'd locate the minimum, but it'll have a minimum value of k, because if you remember, the k was the y value of our vertex. Then we can also say, well, if a is less than 0, what does this imply? Parabola opens downward and we have a maximum at its vertex, which means the location is at x equals h, and then our maximum value is still k. Okay, so our vertex is the most important part. So now, what if it's not in, so I gave this to you in standard form, but what if it's not? What if it's in, so how do we find the vertex if it's not a standard form? Because there are ways around it. If the quadratic function is of the form f of x is equal to ax squared plus bx plus c form, one thing you can do is you could convert this in standard form if you want. But we could also find the vertex if it's in this form. So we can then say, then the vertex is found by x equals to negative b over 2a. And its y value is f of negative b over 2a. So notice how this is the x value, and then to find the y value of the vertex, you just need to plug it into the function. Plug that in for x, and then the output will be your y value. So once again, so if a is greater than 0, what do we know? Our minimum is at x equals to negative b over 2a, and with minimum value of f of negative b over 2a, and then we would say if a is less than 0, the maximum is at x equals to negative b over 2a with maximum value of f of negative b over 2a. Now remember, we're saying the same thing here as I did when we had our equation in standard form. It's just the equation looks different, so there's different ways we could find the vertex. Okay, so let's look at our last example, and then that'll wrap up this section. So for example 2, we're going to say find the maximum or the minimum value of each quadratic function. Okay, so for a, we have f of x is equal to negative 3x minus 1/3 squared plus 4/3. Now, before we do this, we're being asked to find what? The maximum or minimum value. When you hear value, this is the y value we care for only. Okay? If they said, hey, where is the maximum or minimum? Then you tell me where the x value is, right? You'd say, hey, I have a maximum or minimum at x equals this. But since it's saying give me the maximum or minimum value, we're after the y value. So if we look at this, this is in standard form, and since the a is negative, what do we know? This means it opens down. So what is it that we have? We have a maximum, and what do I know? The maximum value is just going to be the y value of my vertex, which is 4/3. So this implies that the max value is 4/3. Okay? Now, for part B, we have f of x equals to 5x squared minus 4x. Now look, since this is a, which is a is greater than 0, which implies it what? Opens down. We have a what? We have a minimum. So our minimum value is going to be the y value of the vertex. So I have two choices of this. I could either write this in standard form, or I could just use the equation x equals to negative b over 2a. But remember, this is only going to give you the location of the minimum value. So to find the minimum value, I'm going to have to plug this in for x and find the y value. So what is it that I know? B is what? Negative 4, right? That's b, and that's a. So this is what? Negative, and then b is negative 4. So this negative is that negative, and that negative is because of the b, over 2 times a, which a is 5. So this becomes what? 4/10, which becomes 2/5. Now, to find the minimum value, that is found when I plug in 2/5 in for x into the function here. So it'll be f of 2/5, which becomes 5 times 2/5 squared minus 4 times 2/5. So let's simplify this. So this becomes 5 times 4/25 minus 8/5. The 5's cancel out. So I get 4/5 minus 8/5, which is negative 4/5. And there's my y value, or the minimum value. Okay, so this takes care of this section. Please, if you have any questions regarding anything from the notes, don't hesitate to reach out to me.